Hello everybody, this video clip is the first clip for chapter 2 of our calculus for business 2. Okay, so this chapter 2, it is about the so-called linear programming. Okay, so let us talk about what is linear programming. Linear programming involves maximizing or minimizing a linear function. Okay, so don't forget that the linear function, it means that or the power of your variables. Okay, so you are going to have variables, okay, and or the power of the variable is of a power 1. Okay, so this is a linear function, and usually this linear function will call an objective function. Okay, and this one you are going to either maximize or minimize subject to a certain restriction, which usually we call constraints. Okay, and this constraint will involve a linear inequality of a linear inequality of a linear equations. Okay, so let us take a look at an example. This example, it says that a company produce two types of widgets. Okay, which is manual and electric. Okay, two type. Each requires in its manufacture, okay, the use of 3 machines. Okay, you are going to use a 3 machine ABC with the data given in the table. Okay, so for the manual, okay, you need to operate your machine A for 2 hours, okay, and machine B for 1 hour, and machine C for 1 hour. Of course, I mean, this one is like 1 unit of a manual widget. Okay, and this one, the profit of the manual widget, it is $4 per unit. For electric, okay, if you do the electric one unit, you are going to use your machine A for 1 hour, your machine B for 2 hours, and your machine C for another 1 hour. Okay, however, each machine has their own limitation of hour available. For example, for the machine A, it can operate for 180 hours. For machine B, it can operate for 160 hours. And for machine C, it can operate for a total of 100 hours. So how many of each type should the company make in order to, of course, maximize a profit? Okay, so I mean, let's take a look, because we talking about like how many pieces of each of the manual or electric that we are going to produce so that it will maximize your profit, right? So basically you can say that, hey, let's produce this manual for X unit. Okay, this one for X unit, and let's produce the electric one for Y unit. Okay, so if you produce X unit of manual, you are going to have your profit for 4x. Okay, so the profit, it is 4x, and if you produce Y unit of electric, you got a profit of 6 each, so you have another 6y for your profit. And I mean, because it is a profit, right, so you need to maximize this profit. Okay, so here you need to do you need to find a maximum of this profit. Okay, so this one, it is your objective function. Okay, your profit, okay, it is your objective function. The objective is to maximize a profit. Okay, so it is to maximize your 4x and 6y. Okay, and usually we call this one it is p of xy. Okay, the function p of xy. So let me just write this way: to maximize your p xy, and your p of xy is just simply 4x and 6y. Okay, do we have some constraint or some condition? Of course, we have some constraint, right? For example, the machine A can operate only for, not beyond 180, right? Not beyond 180. So it means that if you produce 1 unit of a manual, you need to use 2 hours of the A, and if you produce 1 unit of electric, you need to use 1 hour of the A. However, if you produce X unit, then you use your A for 2x hour, and if you produce Y unit, then it means that you use your A for electric one for for this was 2x, this was for Y hour, and then you add it together. It cannot go beyond this limitation, right? So it means that your constraint, okay, it is your 2x and 1y cannot go beyond 180. This is for machine A, okay. How about for your machine B? It is 1x and 2y, you see here, okay, 1x and 2y cannot beyond 160. This one is a total number of hour work for machine B. And how about for machine C? It is 1x and 1y cannot go beyond 100. This one is for the machine C, okay. So here is a constraint. However, there are some other constraints that you may forget, because for example, your X is a number of unit that you are going to produce. Your Y is also a number of unit that you are going to produce. So it means that your X must be positive, your Y must be non-negative, and your Y also non-negative, okay. So you are going to find your maximum of this two variable function, okay, two variable formula, subject to this 5 constraint, okay. So and how are we going to do that? That will be later on, okay. So this is like I told you, here's the typing version of the one that we just explained. So if you don't like my handwriting, you can just look at this typing version here, okay. So now, before you go ahead and find the maximum of this objective function, so let us look at each and every constraint here first, okay. Each of the constraint, it is this one on this side, it is a linear polynomial. This one is a constant, and it is attached by the inequality. So these called the linear inequality. So it means that you may need to know, like, what is this inequality look like in terms of geometric, so that you are going to collect all the x and the y, you see, because this one, the x and the y that you are going to put in your profit to see which one is the maximum, must be the x and the y, or the points that satisfy this inequality, satisfy the second inequality, and satisfy the third inequality together, okay. So you need to know, like, where is these, all the pair x and y that satisfy these 3 conditions, of course together with these 2 conditions, okay. So let's look at the so-called linear inequality in 2 variables, okay. A linear inequality in 2 variables can be written in the form ax plus by plus c less than 0, or it can be less than or equal, greater than or equal, or strictly greater than. And of course, your a, your b, your c, they are constant, okay, and your a and your b are not both 0 together, so that like one of the variables still appear, okay. So if because this one, a linear equation, okay, represent by a straight line, okay, by a straight line, and this straight line, okay, it is easy to find. You can just find like at least 2 points, okay, on the plane. For example, the one that you may look at is that when your x is 0, okay, so if your x is 0, you solve for y, this one will be your y-intercept, and then next you let your y to be 0 and you solve for x. That will be your x-intercept right here, okay? And then after you got your y-intercept and your x-intercept, then you can just simply draw this straight line. We get, and actually this straight line, okay, this straight line, if you talk about the one with equal sign, it means that you are going to use the solid line. Okay, the solid line will represent the equal sign. Okay, the equal sign. However, this solid line will separate your plane into two pieces. Okay, the one that we call the first piece up there, it look like the one up here, and the one that we call the second piece down here. Okay, so we are going to determine which region, okay, which region, because for the inequality, okay, I mean, because this one for the solid line, it means the equality or equation. But if we talk about the inequality, okay, it's going to be like a lot of points, okay, a lot of x and y that satisfy this inequality. It will either be in this region or in that region, okay, depends on like you are going to choose one of the point, okay. So for example, you are picking one of the point, okay, that in region 1 or 2, depends on, you know, the problem, okay. So for example, this one, the point that you may considering is 0 0, and you just plug in your 0 0 into your inequality. If your inequality holds, it means that your 0 0 is included in that region. So it means that you are going to collect all the points on this region, okay, and all the point on this region will be the point that satisfy this inequality. We get, okay. So we are going to, you know, just doing one of the example. For example, this one, the 2x and y, 2x plus y equals to 4, okay, 2x plus y equals to 4. So as I told you, you let your x to be 0, then your y immediately 4, okay, that's your y-intercept. And next, you let your y to be 0, so you have 2x equals to 4, so your x must be 4 over 2, which is 2, so it's right here. So as you got 2 points, you can draw a straight line. So this straight line, okay, the solid one, okay, so let me just draw a solid one here, okay. It is the line representing the equation, okay. So it is 2x plus y equals to 4. So these are points, okay, that satisfy this equation, okay. However, the first region and the second region, okay, the one look like on the top, we call the first one, and then the one that look like on the bottom, okay, below, we call the second one. You just try like picking one of the point here, okay, and then you just plug in, for example, this 0 0, you just plug in into your equation, okay. So it say 0 plus 0 and 4. So this one, 0 and 0 will be less than 4, right? So it means that this region, including this point, must be the region that your 2x plus y always less than 4. We get, and the region up here, okay, you can, I mean, it will be the one opposite, okay. So if this point already make your inequality to be less than, then the one opposite there will be the 2x plus y greater than 4, okay, greater than 4. We get, so we are going to use several kind of drawing. For example, if you're talking about the one with strictly less than, so this is the same example, right? And if you talk about a strictly less than, so it means that you not include the equal one, so you use the dash line, okay, so that it will exclude all the point on this line, but only this point in this region that is considering, okay. Same token, if you have a strictly greater than, so it means that you are not going to include the one with equal, but only all the points that is in this region that you are considering. But if you have the one with equal sign, less than or equal, then it means that you also include this solid line and as well as all the points, okay, that is below here. And on the same token, if you have a greater than or equal, then it means that you include the solid line and also the one above. Okay. So if you're talking about a system, a system, it means that you are going to, incorporate all the inequality together. Okay. So for example, this one, the same old inequality 2x plus y less than or equals to 4, as we did previously, we know that it is the region, okay, that is drawing in black like this. However, if you talk about another inequality that your x is greater than or equals to 0, so it means that you are going to look at the one along, the positive side of your x, and the next one is when your y is greater than or equals to 0. So it means that you looking at the region that is above the x-axis, right? Above the x-axis. So you just look at the common region, okay, among these three inequalities. And you can see that now the common region is only this small triangle, okay, this small triangle inside here. So it is this triangle over here, okay. So usually, these two conditions refer to all the points x and y in the first quadrant, okay, which is this one, the first quadrant. Okay, all right. So let us try to find the region by ourselves first. Okay, the region that we want to find is that your 2x and y greater than 3, your x is greater than y, and your 2y minus 1 greater than 0. So let us try like one by one. So the first one, okay, if you let your x to be 0, your y becomes 3. So here 1 2 3, let's say. And if you let your y equals to 0, your x becomes what? X is 3 over 2. So just pretend that it is equal first. So your 3 over 2 seems to be here. So I just use the blue one to represent this line. However, we cannot use a solid because it is all, it is the strictly greater than. So we do one more time with a dash line, okay, so that it means you don't include the point along this line. However, you are going to determine either you are going to use this one or this one, okay. So I'll just use the arrow, okay, instead of shading the area, because if you do the shading then you get confused later on, okay. You just use the arrow, okay. So you can pick up 1.00 and just plug in, okay. So if your x is 0, your y is 0, the whole thing becomes 0. Is it greater than 3? It's not, right? Can you see 0 is actually less than 3? So if you talk about this something like this, it means that the region that we looking for is not the region including this 0, okay. So it means that you are going to look at the one up here. Okay, so I'll just indicate by this arrow. Okay, the upper arrow, maybe you do it two way right here. Okay, let's look at the other one. Okay, this one is the one that you guys most confused. Okay, so usually you know how to draw x equals to y, right? Which is the straight line passing through 0 and make a 45 degrees. Okay, make a 45 degree with your x and y axis. So this one, I mean the first one, it is 2x and y equals to 3, and this one is actually x equals to y. So again, you have two ways, all right? And each, I mean, this one or that one, I mean the upper way or the lower way, okay, your 0 is not in the region. Your 0 is on the point, on the line. So you cannot use your 0, okay? So you have to use some other point that is in the region. For example, this one can be 1, 0. Your x is 1, your y is 0. And then you just plug in here. So if your x is 1, your y is 0, is it greater than or equal? Of course it is, right? So it means that your region will include this point. So it will be the below region here. So we are going to indicate by this arrow down. Okay. So if you have only these two inequality, okay, if you have only these two inequality, which region that we talking about? This one is this region, this one is this region. So the one that intersect will be this, right? Will be this, okay, inside these two, I mean inside these two lines, okay, but not include this one, only include the one above. All right, and we cannot really ignore this point because we are going to draw the third one. Okay, the third one is actually what, y equals to 1/2, right? So just pretend that it is equal first. So y equals to 1/2, actually, I mean from the picture you may see that, hey, it should be somewhere here and it should be like something like that, okay? But I mean how do you know that it's not going to passing through this point? Okay, so you need to make sure that it's not passing through this point, and you need to make sure a little bit that, okay, I mean your graph need not be that accurate. However, okay, it still need to a little bit give you all information that you need. Okay, it gives you all the right information. Okay, so you are going to find the intersection here first. So sorry, you are going to find the intersection here first. So this intersection, it means that you are going to find the intersection between x equals to y and 2x plus y equals to 3. Okay, so because here you got x equals to y, so you just plug in 2x and 3 and x, okay, equals to 3. So it means that your x is 1, and if your x is 1, of course, because your x and y are equal, your y also 1. So here is actually the point 1, 1. Okay, the point 1, 1. So of course the 1/2 will be below 1, 1. Right, this one is really y equals to 1/2. So we just need to know that whether it is below that intersection or above that intersection or passing through that intersection. Okay, so now we know that it is really below. Okay, however, what we really need is what, not the equal, right? We actually need the greater than. Okay, and as you have the line like this, I mean the straight line parallel to the x-axis like this, it will be the one upper and the one lower, and you can just make a guess that the y that is greater than, so is y that above 1/2, right? So it must be the one upper, right? But if you don't know, then you okay, still can plug in this one because this is the point in the lower region, right? And you plug in your y as 0. Can it be greater than 1/2? It is not, right? Okay, so it means that the region that you choose is not the one including 0, it must be the one above. Okay, so here we just indicate by the upper arrow. Okay, so let's look at it one more time. Okay, if you have the blue and the red together, you got this region, right? The region that it is that they are intersect together, it is region. But then as you have this one with the upper part, then it means that you are going to have this kind of region. You see, this kind of region. So here is the region that you looking for. Okay, here's a region that you're looking for. Okay, and this region still extended. Okay, extended as your x and your y getting more and more, is still extended. So we call this kind of region unbounded region. Okay, all right. I mean, again, if you don't like my handwriting, you can just look at the one that is the typing version like this. So here is the region that we're talking about. Okay, so it's pretty much the same, right? Okay, pretty much the same. Okay, so let us stop right here. Okay, and then next video clip, we are going to go back to our linear programming, and then looking at this kind of constraint and see how the constraint affect the problem. Okay, and then how are we going to solve for the maximum or minimum under consideration. Okay, so we'll see you then. Bye bye.